Hi guys. We're going to talk about the natural base e today, and before that we need to have a little refresher on something called factorial. Some of you may not have seen this before, so we're going to talk about that today. So sometimes in math we see a number followed by an exclamation mark, okay, like 4 exclamation mark right here. That's read 4 factorial. It is not just a very excited 4. What it means 1 times 2 times 3 times 4, which is 24. Okay? So if we did 6 factorial, that would be 1 times 2 times 3 times 4 times 5 times 6, which is 720. And you can see that this grows really fast. Okay? My goal is to have my bank account grow factorially. Okay, so you can see factorial numbers grow very quickly. There are 2 factorials that we have to define though. 0 factorial is defined as 1, and 1 factorial is also defined as 1, because you can't calculate them the same way you did everything else, and it makes math work, so we're going to go with that. So that's what factorial means, anytime you see that exclamation sign. Okay, the natural base e. So this is one of the more unique numbers in math. The natural base e is sometimes called the Euler number. I remember in college reading about this guy named Euler, and then hearing in class about this guy named Euler, and it took me a long time to put together that that's the same person. It's pronounced Euler. His name was Leonhard Euler. He was a Swiss mathematician, very brilliant. Okay, he came up with the number e, and it's defined as follows: e is 1 divided by 0 factorial, plus 1 divided by 1 factorial, plus 1 divided by 2 factorial, plus 1 divided by 3 factorial, plus so on and so forth forever and ever and ever. Okay, now this number grows really fast, which means that this number itself shrinks really quickly. Okay, so what happens is, you get 1 plus a half plus a 6th plus a 24th plus a 120th. The next one's 720th. Okay, and you end up with a limit that ends up to be this number right here, about 2.71828182845.9 da 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 da. It is a irrational number, very much like pi. Okay, and it's a very useful number though. It comes in handy all the time, and it occurs in nature quite a bit. Okay, so we're going to sketch the graph of f of x equals e to the x. Helpful to have a calculator for this. Okay, so your e to the x key is right down here. So if you go down here next to your 4, there's a key that says ln. We're going to talk about that a little later. Okay, the blue key right above it. So if you want e to the first power, that's just e. So, but if we want to say e to the second power, you push your second key, your ln key, and then you put a 2 in there. And sometimes you have to close the parentheses depending on how old your calculator is. Hit enter, and it would be 7.39 essentially. So what we're going to do is we're going to make a table. Okay, and I'm going to put some numbers in here. Okay, so e to the 0 power is 1, because everything to the 0 power is 1. E to the first power would be e, which is about 2.71, so that's going to be right about there. Okay, and then 2 we said was 7.39, so that's going to be what? There's 3, 4, 5, 6, 7.39 is going to be right about there. Let's see, e to the third power, it's about 20, so we're going off the graph really fast. Let's go the other way. Let's put -1 in there. So e to the -1, it's going to be 0.3678. So that's going to be right about here. And what's going to happen is this is going to get closer and closer to the x-axis, but it's never going to quite get there. So it's going to look just like this. This is an exponential growth, and it grows extremely fast. Okay, so there's e to the x power. This is why I said I want my bank account to grow by e to the x power, because takes off, huge. Okay, so simplify some expressions. So the power rules that we've had before all work still for e. E to the second plus e to the third is e to the 2 plus 3 power, which is e to the fifth. Okay? And then 6e to the second divided by 2e. Well, the 2 is going to cancel with the 6 and leave you with 3, and the e is going to cancel one of the e's. So this is going to be 3e over 1, which is just 3e. Okay, and then 2e to the negative 1, I'm going to distribute my power in there, because remember that's 2 to the second times e to the negative 1 times 2 is negative 2. So this is going to be 4 over e to the second, like that. That shouldn't be anything you haven't been exposed to already. Okay, sketch the graph of the function f of x is 0.5 e to the 0.6 x power. Okay, so again, this would be one that I would just make a table. Okay, again, if I put 0 into this thing, it makes this part 1 times 0.5 is going to be 0.5. Okay, so this is going to be like right here. And then if I put 1 in there, I'm going to get 0.5 times e to the 0.6.